Okay, so the next part is called network flow, and there are some networks that allow for flow to be in both directions along a path. Now the easiest one you can think of is a road, because you can go in both directions, okay, a freeway or a road. Some networks allow for flow in only one direction. For instance, power lines. You can only flow from the generator to the house. You can't go backwards. Alright, so copy that and come across. Okay, so the attribute or the direction of flow needs to be displayed clearly on the diagram, and all we do is we just use an arrow to indicate which direction. And the quantity of the flow is a number that we can allocate to the edge. Okay, so copy that and come across. Okay, so let's have a look at some technical parts. So the network starting node is called the source, and the end node is called the sink. The flow capacity of an edge is the amount of flow that an edge can allow through it if not connected to any other edges. The inflow of a node is the total of flows from all edges into that node. Again, when we look at a diagram, you'll make sense of this. And the outflow is the minimum value obtained when we compare the inflow to the sum of the capacities of all the edges leading to the node. Again, copy that down, and when we look at a diagram, it'll make a lot more sense. Okay, so we've got nodes, we've got arrows, we've got numbers. Okay, so A is the source because that's where it starts, and F is a sink because that's where it finishes. Okay, leading into B is 100, so it has an inflow of 100 whatevers, and coming out of B, the outflow from B, the outflow is 30 plus 20 plus 10, so the outflow is 60. So obviously it's not using all its inflow, it's got some reserves, but that's the first part. So we've got nodes, we've got source, sink, inflow into B was 100, but the outflow was only 60, so it has an excess of 40. Okay, so copy that and come across. Okay, so A is the source, and whatever that is the sink. Okay, so what does B have this time? It has an inflow of 100. Now this time its outflow is 130, but it can't get to 130, so its outflow must still be 100. Okay, even though we've got more than 100 there, it can't flow out more than it flow in. Okay, so where the difference is, that's still to be determined whether this one loses. So there's a deficit of 30, but where the 30 comes from, that's still to be determined. Okay, copy that and come across. Okay, so the flow capacity of the network is the total flow possible through the entire network. So the flow capacity is the flow possible through the entire network. Any excess flow capacity is surplus of the so excess flow capacity is the surplus of the capacity of an edge less the flow into the edge. So on that first one we had an excess of 40 because we had 40 that wasn't being used. Okay, so copy that and come across. And that's it. Nothing left on that last page. Okay. Done. Bye.